So this is the TEST-2F portion for class 10 science chapter 2, acids, bases and salts. Okay, after you complete these questions that are written here, you are going to appear test here 2F. Pause the video and write them down and replay it and join here. Okay, now let us start with 73 and go to 72. Now let us see what is a salt. Okay, to understand it, let us just take some few examples. Let's take the very common acid called, write it a little bit below this line, hydrochloric acid. All of us know this one, hydrochloric acid. The formula is that of hydrogen chloride, HCl, dissolved in water. Usually acids and bases always dissolve in water. Then a base, very common one. Let us take that, sodium hydroxide. Remember your starter and make it Na plus OH minus. So when you do this reaction is going to be quite simple. You can follow a trick. Take the positive from the base. So this is the acid and this is the base. Primarily we're reacting acid with a base, and the negative comes from the acids. So when you combine this box, we normally write the formula, the plus, Na plus first and Cl minus second. Normal way of writing a chemical compound. So this is nothing but your sodium chloride. Okay. Then the side product here, outside the bracket here, outside the box rather, OH plus H. The only correct compound you're going to get is H2O water. So when an acid reacts with a base, you get a substance besides the water. That substance which is formed is called nothing but the salt. So our definition for salt, we can easily understand now. A compound like sodium chloride formed by reaction of one acid with a base, sodium hydroxide. This sodium chloride, that type of compound is called a salt. Let us take a few more examples. Let us take here the same acid, HCl. Okay, and then we take another base. Let us say we took here ammonium hydroxide. We know that this is a base from our earlier videos. So in that video here we studied some common acids and bases. So remember your starter, then you can write the formula. Ammonium ion NH4 plus, hydroxide OH minus, dissolve in water, right? Because unless water is there, the acids will not release hydrogen ion and bases cannot release hydroxide ion. So we can follow the same trick. Positive part usually comes from the base, and the negative part comes from, not usually, always comes from the acid. So when you mix this box, we write the positive NH4 plus first and Cl, the negative. So we, on the left, the boxes on the left can fit to form this correct compound, which is nothing but, if we remember our starter, this is ammonium chloride. So the salt here is ammonium chloride. And like in the first equation, outside the box, OH plus H, water. So usually in the acid-base reaction, water is usually formed as a byproduct. Okay, one more example. We can take here the acidic acid, CH3, COOH. Okay, and then you take the same base here, sodium hydroxide, dissolve in water. Okay, if you want to put that, then here it's good to put, right? So here again, now box this, the negative one comes from the acid and the positive part comes from the base. Now normally in majority of the compounds, positive part is written first, like Na plus Cl minus, NH4 plus Cl minus. But this type of compounds having acetate radical, they usually have the ulta way. Okay, instead of positive first, the negative comes first. So this is an exception. CH3 CO minus comes first and the Na plus goes back. So the compounds containing acetate radical or ion, usually the negative appears first and positive appears at the back, which is not the norm or the normal way of writing, but this is an exception. So this is nothing but sodium acetate, and this is therefore the salt. Okay, sodium acetate. If you want, okay, so it's okay. This is the salt. Now here, outside the box, OH plus H again is water. So usually, not in all, but majority of the acid-base reactions, we always get salt. And in most cases, we get water as a byproduct. Except in few cases, we don't get water, okay? So this type of compounds formed by acid reacting with base, this type of compounds are called salts. Now there are different types of salts. To classify them, one very common way of classifying salts is this. First type of salt, classify, right? Like you classify means group into different groups, like boys, girls, blue house, green house, something like that. So one way of classifying salts is neutral salt, acidic, basic, like that. So what is neutral salt? Now look here. Go to question number 54 and 55 of your tuition note. The question there is, what are strong acids and bases? And 55 is, what are strong and weak bases? There you'll see examples of strong acid, weak acids, strong base, weak bases. You'll find that this hydrochloric acid, if you go and check there, okay, pause the video and write it first and then join for the next question by replaying your video. So you'll see HCl as an example of strong acid. Check question number 54, you'll find out. Then NaOH in question number 55, you check, you'll find this is a strong base. So this first case is this salt here is derived like this, see, sodium chloride. This is the salt we put in our sabji everyday cooking, without which the sabji will be tasteless, right? So this salt derives the positive from the strong base Na, and chloride ion Cl minus, it derives negative ion comes from the Na plus comes from the strong base, and Cl minus comes from the strong acid. So this type of salt derived from strong acid reacting with strong base are called neutral salts. Okay, strong salt of strong acid and weak base, strong acid and a strong base, it's called a neutral salt. Yes, and when it is a neutral salt, the pH is usually around 7. Okay, pH value, and the example therefore is sodium chloride, NaCl, the white nimok that we put in our sabji salt. Okay, then next here, you know that this question number 54, you'll find this is a strong acid, NaCl. And go to question number 55 and you'll find this ammonium hydroxide is an example of weak base. So when a salt like ammonium chloride is formed from reaction of strong acid like HCl with weak base, that salt NH4Cl is called a acidic salt because its acid is stronger here, weak base. So the character of the salt will show dominance acid character, so it is called acidic salt because the acid is strong, so it will dominate over the weak base and portray itself as acidic salt. So salt formed by strong acid and weak base are called acidic salt. Yes, and since this is acidic salt, the pH will be less than 7 because we know pH less than 7 is acidic, right? Salt of a strong base and weak acid. Last one. Now we know question number 54, this is definitely weak acid. Okay, weak acid, acetic acid. Sodium hydroxide is a strong base. See question number 55, you will find sodium hydroxide as an example of strong base. So when weak acid react with strong base or strong base react with weak acid, the strong base will dominate over the weak base and it will appear as a basic salt. So these are called basic salts. This one here, sodium acetate. So example here is CH-2, COO, and a sodium acetate is a basic salt because it is formed from strong base reacting with weak acid, and so strong base dominates over the weak acid. Okay, so pH, because it is basic, pH will be greater than 7. Anything basic is greater than 7. 73, 72, important. Okay, so salts can be classified to 3 types: neutral, acid, and basic salts, depending on the types of strong or weak acids and weak or strong bases the salt is formed from. Now, before we go to next question, one important thing. In every of these salt, you'll find out that Na+, the positive ion, which is also called cation, comes from the base. Therefore, positive ions are also called basic radicals. Go to starter and check it and see. And then Cl minus, the negative ion or anion, comes from always the acid. Therefore, Negative ions are also called acidic radicals. Okay, so I hope you're getting it. Now 72, 3 done. Let us go to 82. Now in this first question, what are salts? Give an example if a question comes like that. I've given 3 examples, but that's not necessary. For you, it will be only 1 example is enough, okay? Unless they ask for more than 1 example. Okay, next question number 82. Question note. Even if you don't have tuition note, pause the video, write it. This is as good as tuition note. If you have tuition note, then you can mark those things in tuition note, and when you come to some part, you'll also have to write, even if you have tuition note, okay? 82. Okay, so this part you can just look on your note if you have, otherwise write it down. How is this is just a matter of writing it down, so write along with me. Those who have note, do it on your tuition note. Chemical name of baking soda, chemical name of baking soda, okay, used in baking cake, bread and all in baking, is, know this one today, sodium hydrogen carbonate, or you will also see like this in some textbooks, sodium bicarbonate, because bicarbonate ion and hydrogen carbonate ion are the same thing, one and the same thing. HCO3 minus, right, is this one, okay, and its chemical formula, so here, and its chemical formula. So we're going to learn how to write the chemical formula from the chemical name. You will get the chemical formula, the clue, only from the chemical name, not from the common name. Common name is baking soda. Chemical name is sodium hydrogen carbonate or sodium bicarbonate. So sodium ion from your starter, Na plus, bicarbonate ion, HCO3, 1 minus, both valency 1, so that's the formula, NaHCO3. So this question is basically knowing what is the common name, baking soda, chemical name, sodium bicarbonate, chemical formula. So learning to do that, okay? Now 82 done, so 86. Let us go to 86. Question 86 is basically uses of baking soda. Write the uses of baking soda. Okay, baking soda. Let's start. I think it's put as A, B, C, so we can just do that. A, used as a component. It is used as a component of baking powder. Don't get confused. Baking soda is not baking powder. Baking powder is not baking soda. You will soon come to know. What is baking powder? It is simply has 2 ingredients. One, baking soda, the common name. Real name is sodium bicarbonate. Formula is NaH. So baking soda, this one is used as a one component, important component of baking powder. The second component of baking powder is always an edible acid, like a tartaric acid, or some even use, I think, citric acid. This acid that is used here should be edible, means because it's going to use for baking, so it's going to go to the stomach, so it should be edible to the human stomach, tartaric acid. Now, so that is the first use. How it is used? Let us see. This is important. Now, baking soda here, when mixed with this one here, what is that? Here, tartaric acid means H plus, because the ion H plus acids are those substances that release hydrogen ion. So acids can simply be represented as H plus also. So this is the tartaric acid. So when acid react with base, you know you get salt. Salt of whatever acid and bases you are using, okay? Plus, we know that water is released. But in this case, it is special because sodium carbonate is there, so it is releasing carbon dioxide. Now this is the key function. Because baking soda contains CO3, when the acid react with it, the acid releases the CO2 from CO3 and releases this one. And this is very important because the carbon dioxide here rises up, okay, rises up and makes holes, chendal, small holes in the dough. Dough means atameda, okay, dough. So making the cake or whatever fluffy, or bread fluffy and spongy. So that is the first use of baking soda, because when you react with the acid, tartaric acid, it releases the carbon dioxide, which rises up, making small holes in the bread or the cake, making it fluffy or spongy. Otherwise the cake you bake will be very hard to eat, right? So that is the first function. Okay, now here, see, this is the function of baking soda. Now let us see the functions of the tartaric acid or the edible acid, citric acid, whatever acid. The function of the acid here is, one, it helps release carbon dioxide from baking soda and NaHCO3. So when you don't put the acid, the carbon dioxide won't come out, so the cake won't be fluffy, so that it helps to release the CO2 from the baking soda. Second function is this one. Number two, here, since baking soda is alkaline, alkaline is another word for basic. Alkaline or basic is the same meaning. Since baking soda is alkaline, it is bitter. All bases are bitter. Now, the first definition of acids and of bases in the first part of the first video is bases are substances that are bitter in taste. We studied that. So it is bitter. So what is the problem? So even though it releases carbon dioxide and the cake is fluffy and spongy, it will still be bitter to taste, which is undesirable. So how is that problem overcome? So the acid, whatever edible acid is there, neutralizes, because it is opposite. So it is basic, so it will only a base or an acid can neutralize this basic baking soda. Neutralize, can acid neutralize is a standard word or simple word, cut the bitter taste. So the acid is there to help cut the bitter taste. So the function of tartaric acid is to release carbon dioxide from baking soda and to cut the bitter taste from the baking soda. Okay, so those are two functions of tartaric acid. Function of baking soda is, of course, it has the potential to release carbon dioxide, but it needs the help of the acid, right? So this is the first one. I hope you got it. Second use. Okay, number 2B. Now you see here, since baking soda, okay, right along with me, is alkaline. Alkaline means basic. It neutralizes, just write it down first, neutralizes stomach acidity. I'll explain it to us. So it is used as antacid. So we must know what is antacid. Antacid is a base that cuts the excess acid in our stomach and gives relief to the stomach pain. Now, what is gastritis? When every one of our stomach has some secretes or release some amount of HCl, okay, which is good. But when we overeat or something, a lot of HCl is released and it causes irritation in the stomach, pain, which is called gastritis. So only a base or alkaline substance like baking soda can, if we put it in our stomach by drinking this solution or suspension, then only that base can cut that excess acid. No, so when you have that condition, if you stir the baking soda, white powder, drink it, it can cut the excess acid and cause relief in the stomach. So those type of substances or medicines are called antacid. Antacid are basic substances that cuts the excess acid causing irritation in our stomach. Okay, so gastric medicine. So next, third you see is baking soda is used in some fire extinguishers. That means when fire starts, these fire extinguishers are used to douse the flame, right? So baking soda is used in some type of fire extinguisher. So those are the 3 important uses of baking soda mentioned on your text. Okay. Now once we're through with that, that is also the last question, 96. And question 96 is there. Briefly explain how doctors, just write in short, use plaster of Paris. Plaster of Paris. Now let's just try to explain this. Now when you someone fractures his bone, arm bone for example, then the doctor has to straighten the bone again. How does he do it? He straightens the hand and then put in proper place and then take that white powder called plaster of Paris, make a cast. How does that happen? Plaster of Paris is the common name of the white powder that the doctor is using. The real name is, you write along with me, calcium sulfate hemihydrate. So you can write the formula by looking at this name very easily without memorizing. So calcium though you know CH2 plus, sulfate SO4 2 minus, so 2 cancel valency. Dot hemi means we know half. Hemi, northern hemisphere means half of earth, upper half of air. Southern hemisphere, see, half. And hydrate means water, so H2O. So the doctor will mix this white powder with the water, okay? Water, and every molecule of calcium sulfate hemihydrate will combine with 1.5 water molecule and form. I join this, just simple, nothing hard. CSO4 is there, join it. Only the one, then half plus 1.5 we know is 2. Right, half plus 1.5 is 2, right? Common sense also, 1, half, 1. 1 more is there. So half, 1, 2. So 2 H2O. Now the compound having this formula is called gypsum. Now what is the special property of gypsum? It is a hard mass. Calcium sulfate hemihydrate is just a powder. It cannot cast. But then when you mix with water, you form gypsum, which is a hard mass. So it's like cement plastering and forming a hard mass on the wall to keep the wall strong. Something like that happens on our hand. So the white mass soft, he puts it like this, cast it. And then after some time, it formed a hard mass. The sulfate hemihydrate changed to gypsum, which is a hard mass and is able to be like cement plaster, holding the 2 parts of the fracture together for 30 days, 40 days, till the bone has stuck together in the right places. So that's how doctors use plaster of Paris. Okay, 96. Then let us go to 2 more questions are there. Let us go to question number 5, tuition note. Page 75, if you have the tuition note, you can do it there itself with your pencil. If you don't have, just follow me. Question number 5. Page. Okay. Question number 5. Page 75. Tuition note. Write on, full thing, tuition note. Or this one will appear as question number. This one will be on the textbooks. This is a textbook question. Textbook, page. You open to page 35. Those who don't, if you have also, you can go. Important question. Let me read the question. That question on your textbook, page 35. Write word equations and then balance equation for the reaction. Write word equations. So very important question, this one. Word equation. First you write the word equation. Okay. And then balanced. Write word equations and then balanced equations. And then balanced. So we have to balance. Keep your pencil ready. Balanced equations. Balanced equations for the reactions for the reactions taking place when, okay, number A, dilute sulfuric acid. Write along with me, okay? And those who have tuition note, go to your tuition and do directly from the dilute sulfuric acid reacts with zinc granules. React with zinc granules. The word granules simply means solids, small pieces of solids. So here, let's do that. Right here, so keep some space and write with your pencil now. This one you can write with pen, now pencil down here. Dilute sulfuric acid. We know this formula, H2SO4, so write it down. Acids always dissolve in water, so AQ. React with zinc means right here, just below the plus zinc. Now we know zinc ion is Zn2 plus, but this is not zinc ion, this is zinc. So zinc means simply the atom no charge, okay? It's a solid. So if you want to put S, it's not so strict if you don't put also. But writing the formula correctly, okay? Write the word equation first. Okay. Write word equations. Okay, sorry. Let us start with word equations. So I write, follow me, dilute sulfuric, word equation is this one. Sulfuric acid, just write in words plus zinc, you write zinc, gives you like this word equation we have to write. So zinc, then you see zinc and sulfuric acid. So let us just start the both. Then the sulfuric acid is here, we know H2SO4, AQ. Zinc we know as just now a solid. Now we don't need to memorize the right side in most equation. Now go to page 47 of your textbook. There's a table called reactivity series of metals. Now if you check, zinc is a metal above hydrogen. Go and check. Yes or no? Yes, that's right. So it is more reactive than hydrogen. So it'll push up the replaceable hydrogen in the acid here, and the gas will come out in gas bubble. So hydrogen gas will come out. Even if you forgot to put G, that's fine. Okay. So here in word you write here hydrogen. This is the word. Plus this will go and push out the hydrogen and takes its place. So if it Zn replaces and combine with SO4, remember your stutter, Zn is zinc ion, SO4 sulfate, yes. So we'll get here zinc sulfate, Zn2 plus, SO4 2 minus, so 2 cancelled. So you write here the word equation, zinc sulfate. So this is what is called the word equation, written only in words with the arrow in between and plus in between the reactants on the left side and product means on the right side. Now, this equation that you've written just now with the formula is called the skeletal equation. Okay, this one is called skeletal. This is word equation, this is skeletal equation. Meaning, this skeletal equation means written with symbols only and no attempt is yet made to balance them. Not yet balanced. Or maybe balance, but you didn't try to balance. It's called skeletal equation. Now we have to balance. So let us go and see. For that, normally we write here. Okay, you can write that table. Atoms like this. And then left hand side, right hand side. So as you start dealing with chemical equations, you can make table like this quickly. And once you get comfortable, you can stop making it. First atom I see is hydrogen, so I write there. Left hand side, 2 only, no more, so I write here 2. With your pencil you do this because you need to rub out, okay? The only way to balance chemical equation is by trial and error. Means we try, and if we make mistake, we try again. And as you keep on doing, we gain confidence and it becomes easier to balance. There's no other way, okay? H2, here also 2 on the right, no. So far, left hand side 2 hydrogen atoms, right hand side 2 hydrogen atoms, so it's balanced so far. And let's go to the next atom called sulfur. Here 1. Number of atoms is at the back as a subscript. The front one is not there. Here is not the one that belongs to S. The 2 that is in front of S actually belongs to H. Sulfur atom is at the back. No number means 1. So we write here left side 1. No sulfur here. This is not sulfur, this is solid. Here 1. So far balanced. Then O, 4. Here also 4 at the back. So we write here O, 4 on the left, 4 on the right. So far everything is balanced. Then we go to Zn. Here Zn, 1, here also at the back. No number means 1. So in this equation, everything is balanced. So now, this is the balanced equation. So this is how we write. First one is the skeletal itself is balanced. We don't need to balance. Let's go to the B. Okay, B. B is dilute hydrochloric acid reacts with magnesium ribbon. Dilute hydro, and the question is given like this, chloric acid reacts with magnesium ribbon. The word ribbon here is not so important. It means it is in the shape of ribbons, that ribbon used for binding gifts and all. Okay, but the word magnesium is more important. So we write the word equation. Word equation means in word, like this, in English words. Hydrochloric acid, N means plus, reacts means plus, magnesium. Magnesium ribbon or magnesium is enough. And what is one going to go on the right side? Let's try from here now you write the formula. HCl, hydrochloric acid, in water, or HQ. And magnesium means Mg, the solid. Now go and check again. Magnesium on page 47 of your textbook. It is above hydrogen now. Yes. Then it will release the hydrogen gas. Hydrogen gas is H2, okay? So hydrogen atom, this is hydrogen ion, this is hydrogen gas or hydrogen. Hydrogen means the gas. Okay, G in the bracket, okay? Then now if so you get in word here hydrogen plus this Mg take this place means Mg and Cl in the starter, magnesium and chloride. So magnesium chloride. Magnesium chloride is the next compound. So make the formula Mg2 plus Cl1 minus. So 1 and 2 can cancel. 1 at the top of Cl will go here, but no need to write 1. 2 at the top of Mg will go to the lower backside of Cl. MgCl2, right? Now, here, whether you write this H2 first or MgCl2 first is not important. You can write MgCl2 also first, okay? And H2 back. The substances on left should be correct, but position Mg come first or HCl come, that's up to you, okay? Now, this is called a skeletal equation because we have not yet tried to balance. It's called skeletal equation. Let us check what we should do now. So in this, make a box yourself again with your pen, okay? Just quickly make the box. And the atom here is hydrogen first. With your pencil you do this. Then here, left side 1, right side is 2. So it's not balanced. So to make it equal, we are not allowed to balance in between or at the back or right in front. So to make it equal, I write here 2H. And I rub with my rubber eraser. Now it's equal. 2 on the left side. Now, this number which is right in front is called the main script. The main script will now belong to every atom after that, okay? These ones at the back belong to only Cl, not to this one. But if it is right in front, it belongs to both after that, or 3, whatever is after it, till the next plus sign, okay? So 2H and H2, so balance now. The moment you do that, the next atom is Cl. So 2 belongs to that also. So no number here means 1. 2 ones are 2, Cl on the left. On the right, also 2, so it's balanced. Mg here 1, so right here, Mg, the next atom is 1 on left side, right side also 1. There are 3 types of atom on the left, H, Cl and G. Same atom will appear on the right. In a chemical reaction, whatever atoms are on the left will also be on the right. Nothing extra, nothing will be lost. This is called law of atomic conservation, okay? Now here, every atom on the left is equal to the atoms on the right. So this is now balanced chemical equation. Okay, so next here, C. Let's go and do C. And C is dilute sulfuric acid reacts with aluminum powder. Dilute sulfuric acid reacts with aluminum powder. So let us write the word equation. Dilute sulfuric acid reacts means plus, aluminum powder means you can just write aluminum to give what? Let us see. We know the formula of H2O. So dilute sulfuric means acid means H2O. So for aluminum is Al, which is the solid. Now go and check page 47 of your textbook again. And aluminum is surely a metal above hydrogen again. Check. Yes. So here it will be more reactive. So it will easily push out the hydrogen gas. It will come out and take its place. So Al and SO4 means aluminum and sulfate. So you will get here hydrogen, word equation, plus aluminum. The clue is If you observe the left side, you'll get it. No need to memorize. Aluminium, Al, SO4 means aluminium sulfate. It's because SO4 2 minus is sulfate radical, right? So here now, look at this and remember your starter. Al3 plus, aluminium ion. Sulfate ion is SO4 2 minus. Don't write there. 2 and 3 are the valency, which can cancel. So 2 at the top of SO4 will go to the lower backside of Al, and 3 at the top of Al will go to the lower backside of SO4 only after bracket, because sulfate is containing more than one atom. See here, sulfur atom and 4 oxygen atom. Any ion containing more than one atom is called a compound ion. So if it's compound, the valency you're bringing down is more than 1, like 3, compulsory to put bracket. Here you didn't put bracket because Al is only one atom, aluminium atom. So simple ion, so we don't need to put bracket. So that is the formula of aluminium sulfate. Our next job is to balance. So make a box like this again. Okay, pause the video and replay it if you need time. Now, first atom here, hydrogen. 2 on the left, 2 on the right. So far balanced. With your pencil, you do the inside the boxes. Outside, you mark it with pens and write it with pens here also. Sulfur, 1, and right side also. Now here, this bracket means these 3 belong to everything inside. So 3 ones are 3. 3s, only 1s. So we need to balance this. So here, to balance this one, 3, you cannot do anything but just put there 3. 3 into 1, 3s now on the left side. Now that will match up with 3 on the right, right? Then here, H and S down.